Another criterion that we want to talk about is what's called well-defined. Well-defined means how complete or how full or how precise is the language definition. If a language is not precise, what would happen is that very quickly multiple dialects of the same language would form. We gave an example earlier from C++, for example, H of G of F, where we asked what gets executed first, the G or the F. And we said this is undefined in C++. Undefined is not a good sign, which means there are things here that are not defined. Sometimes a language will say we did not define it purposely, but sometimes the lack of well-definedness is a function of lack of paying attention. For example, back in the 50s, there was a language, the French and the Americans got together and they formed a committee to create the language. And they created a language called Algol, which is probably an algorithmic language or something like that. And the version is 1960. And that language, which is pretty much a game changer, meaning that it back then, it created all kind of things like structured programming and things that exist till today. And it really solved all kind of problems that existed back then. And if we go and we look at a language tree, we will see that many languages today are actually descendants of Algol. So here I just pulled off the internet, just what an internet programming language family tree. And there's hundreds of them, and there's some more complicated and some less complicated. But you can probably see that Algol up here, up on top, is pretty much the forefather of many languages, like Scheme, C, Smalltalk, which is the forefather of object-oriented. We have over here PL1, which became Pascal, transfer to Pascal, which went into Python, and you can actually say it went into others. You can actually see that Algol is actually one of the forefathers of many languages that follow after it. But Algol itself never actually caught on. And the reason why it did not catch on was because of the well-definedness problem, meaning that they wrote the specification of Algol in natural language. And the problem with natural languages is they can be interpreted by different people in different ways. So what happened was first we had the Americans, and then we had the French. And the Americans read it one way, and the French read it another way. And then even within the American community or the French community, one compiler wrote it one way, and one compiler understood it another way. And very quickly, there were many dialects of Algol. And what happens is when you have many dialects, so one programmer could write a program and one compiler, and he doesn't know why. And then another program takes a program somebody else wrote and compiled it, and his compiler and one compiler doesn't understand why. And therefore, it never really caught on. The language itself never really caught on because of this problem of being not well defined. If a language is well defined, it stops all these things from happening. Now, back then, because of this problem, so two guys that you probably heard about the compilers course got together. We had Bacchus Nauer, these are two guys, and they created the Bacchus Nauer form, which is should we say, a semi-mathematical way of describing the syntax of a language. Meaning we don't want to talk in a natural language. We want to talk in a way that there won't be two dialects. By the way, they both got Turing Prize, but not necessarily for this work, but for a lot of other work. But they got the Turing Prize, these two guys, Bacchus and Nauer, but they created the Bacchus Nauer form. And the compilers course, you actually learn about this form. In this course, in a future lecture, we will talk about BNF, the Bacchus Nauer form. But that was created in a sense because of the problem of well-definedness, which means that Algol was the example of a language which was not well-defined. It was defined in a natural language, and hence it created a big problem. The solution was BNF and other things, but that was a problem. If you have a language that's not well-defined, you might not want to use it. You might say, I want to use it anyway. But you might say, I don't want to use it, and I'd rather use a different language. So what I described so far was all kinds of criteria criteria for actually deciding between languages. These are not criteria that have to do with shortness of hand, even though it includes it, for example, writability. It is not a criteria that deals with other things. It's a criteria that has all kinds of other ideas of a more higher level ideas of deciding between two languages. So if you had to decide between two languages for your project, you might say, okay, I rather go and I rather uh, use this language because the cost is too high to use another language. Or I might say I rather use this language because I need portability. Or I might say that I want to use a certain language because it's maintaining the code afterwards is imperative, and if I want a language that's easily readable, and I don't want a new programmer coming in and trying to maintain some cryptic code that some other programmer wrote, I might decide that generality is important. I might decide that reliability is super important. For, think Boeing, or I think NASA. I might decide all these criteria have to go and have to decide based on them which language do I rather use.